Hello everyone, welcome to homework 10. And the first question, we need to do some collecting work about the definitions and the simple properties of some important processes. The first, we look at the Poisson process. We have if x0 equals to 0 and the number between t2 and t1 is the Poisson distribution. So and this is called the Poisson process. The mean is lambda t, and it's reasonable because the longer time we wait, the larger we expect it, and the autocorrelation function is like this, and the points in non-overlapping intervals are independent. So we have the time to wait for the bus in the morning does not affect the time in the afternoon. It looks reasonable. And the second, we look at Poisson increments. It's a function. It's a function in this formula, and this is Poisson increments process. So we have the distribution function is like this, and the probability matrix is like this, and lambda t equals to, and the expectation is lambda, and we can see that the mean is a constant, and the autocorrelation function is like this, and we say it's a function of tau, so the Poisson increments process is WSS. And third, we look at Poisson impulses. It's in this formula. So the expectation is lambda 2, and the autocorrelation function is in this formula. Hence, is WSS2. And fourth, we have semi-random telegraph signal. We have xt equals to 1 or minus 1 in the same probability, and pk is this. So we have p xt equals to 1 equals to this one, and the probability that xt equals to minus 1 is like this. So the expectation eta t is e minus 2 lambda t, and the autocorrelation is like this. It's a function of tau. And fifth, we have random telegraph signal. The difference between random telegraph signal and semi-random telegraph signal is that random telegraph signal x0 equals to 1 or minus 1, and semi-random telegraph signal is that x0 equals to 0. So we have these definitions, and we have this one. So we have found the expectation is 0, and autocorrelation is a function of tau, so it's WSS. And sixth, we look at random walk. We are familiar with this, and the expectation is 0, and autocorrelation function is like this, and the mass distribution, the probability mass is like this. So mean is 0, means it will come back to the origin point eventually if n is large. And seventh, we look at linear process, which is known as Brownian motion in Chinese students. The definition is like this, and we find the expectation is 0, and autocorrelation function is like this. So we can find that Wt is continuous but no derivative everywhere, and the distribution function is like this. And that's all. Thank you.